IGCSE Computer Science, Syllabus Statement 1.3.4f, describe the principles of operation of speakers. And, yeah, speakers. There aren't as many output devices as there are input devices, I think. I'm not entirely sure about that, but I know that the output devices videos will tend to be quite short compared to input. Actually, I have no idea. But anyway, so a speaker is a device that converts electrical impulses into sound. And when we say speakers, we mean loudspeakers or headphones. So anything that speaks or outputs sound. So sound is produced from a computer by transmitting digital values through a DAC, and then through an amplifier, and finally to the speaker, where it is output. So here's the computer. Digital data goes to the DAC, analog data comes out, amplifier, amplified data goes to the speaker, and this outputs the amplified data. So the rate that the DAC can convert the digital data into analog voltages is known as the sampling rate. If the DAC is 16-bit, it can accept 2 to the power of 16 numbers. So that's 65,536. So that would be negative 32,768 to positive 32,767. So that range is 65,536 values, including the 0, of course. The speed that these values can be converted is the sampling rate. The typical sampling rate is 44,100 hertz, or samples per second. This means that the DAC is able to convert 44,100 values every second. So let's look at an example. A CD is being produced to hold a number of music files. Each music file will be sampled 44,100 times per second, each sample being 16 bits. We must also take into consideration the music being stereophonic, or stereo. Taking the above into account, we can calculate how many bits per second can be sampled to the CD. So we have 44,100 times 16 times 2. Well, where does the 2 come from? Well, we say that it's stereophonic, so that's where the 2 comes from. So that would give that many bits per second, and 8 bits is 1 byte. And so we just divide that by 8, and we get 176,400 bytes per second.